Single agent and multi-agent systems both work. The problem is choosing one without understanding the trade-offs. If you are trying to decide whether to keep a single agent or introduce multiple agents, this video breaks down the trade-offs you are actually facing. A single agent system doesn't usually fail all at once. It starts by feeling less predictable. The answers still sound confident, but small changes begin to produce very different results. Debugging takes longer than expected. Edge cases multiply. At that point, it's no longer about model capability. It's about whether the architecture fits the problem. A single agent system is one continuous reasoning loop. One model holds context, decides what matters, plans the next step, and takes action. It can retrieve information, call tools, validate output, and even reflect on its own reasoning. But all of that happens inside a single cognitive thread. This is why single agent systems are so common in production. They are easier to reason about. State is centralized. When something goes wrong, the failure is usually traceable. For things like RAG pipelines, copilots, or structured decision support, this works extremely well. Until responsibility keeps piling up. Planning, retrieval, formatting, validation, safety checks, and tool selection, all competing inside one loop. At that point, the system isn't failing because the model is weak. It's failing because too many roles are being combined into one agent. That's where multi-agent systems enter the conversation. Instead of stretching one agent further, responsibility is split. One agent plans, another executes, another reviews. Each agent has a narrower objective and a simpler internal prompt. For problems that truly benefit from separation of concerns, this can improve quality and clarity. But there is a trade-off that's easy to miss. Complexity doesn't disappear, it moves. In single agent systems, complexity lives inside reasoning. In multi-agent systems, complexity lives between agents. Consider a research assistant that starts as a single agent using retrieval and tools. As requirements grow, a planning agent is added to break the work into steps. Then a reviewer agent is added to check accuracy. Now progress depends on handoffs. The planner waits for the reviewer questions the plan, the executor retries the same step. Nothing is technically broken, but forward motion slows. The hard part is not to generate answers, it's keeping the system aligned. This is why multi-agent systems often fail differently. Single-agent systems tend to fail quietly by getting overloaded. Multi-agent systems tend to fail noisily by getting disorganized. Control is another important difference. Single-agent systems are easier to constrain. Schemas, guardrails, and validation logic are simple to enforce when there is one decision maker. Multi-agent systems introduce autonomy by design. Each agent makes local decisions that influence the overall outcome. That autonomy is powerful for exploration and open-ended problem solving, but it is harder to manage in systems that require determinism, auditability, or compliance. Cost scales differently too. More agents mean more model calls, more state to manage, and more infrastructure to maintain. If a task doesn't clearly benefit from specialization or parallel reasoning, that overhead rarely pays off. Which leads to the most important point. This is not a binary choice. The most reliable system in practice are hybrids. A single agent owns the goal, the state, and the final decision. Other agents are invoked deliberately, not constantly. A planner when complexity demands it, a reviewer when correctness matters, an execution agent when tools are involved. But there is always a clear center of control. So when deciding between single agent or multi-agent system, don't ask which one is more advanced. Ask where your complexity belongs. If reasoning is breaking down, more structure or more agents may help. If coordination is already fragile, adding agents will make it worse. Models don't fail first, architectures do. And the real trade-off between single agent and multi agent systems is deciding which kind of failure you are prepared to manage.